This video is to help you with CUA1 review over functions for pre-calculus. You can decrease the speed of the video or increase it accordingly if needed. We're going to go through these problems. Number 1 says describe the left and right behavior of the function graph below. So this always starts with the left side is called x approaches negative infinity, and the right side is called x approaches positive infinity, because this way we're going to negative infinity, and this side is positive infinity for the x-axis. So if we go look on the left side where we're going towards negative infinity, the graph itself is going upwards. So we would say f of x, or we can call it y, approaches, and it's going up to positive infinity. On the right side, the graph's also going up to infinity. So we can say f of x or y approaches infinity. If either one of the blue or green pieces was going downward, we would write negative infinity. Number 2 says graph and sketch each function, then describe it as even or odd by filling in the blanks. So I'm going to add Desmos. You have a calculator. And I'm going to go to Desmos and I'm going to type in y equals x raised to the 5th minus 3x to the 3rd. And then this graph is what I'm going to copy down onto my picture. So I'll make this small for a second. And I'm going to copy that down. So here's the middle, and no judgments on the drawing abilities because mine might be a little subpar. So it starts down and it goes up and comes back and kind of wiggles through and then goes back up like this. So if you look, the function is blank because it has symmetry with respect to the blank. Well, it has symmetry with respect to the origin. This top dot right here went through the origin down here. This arrow right here went through the dot and reflected over here. So respect to the origin, which means it's called odd. Remember, origin, odd, origin, odd. I'm going to repeat the process. I'm going to add Desmos again. And I'm going to graph the other function, which was y equals, and I have the absolute value symbol. Oops. Hang on, I put the negative up front. Negative absolute value of x, and then absolute value symbol, and then plus 5. So this looks like an upside down V that starts at 5. So I can put that on my graph as well. So we'll call this 5, upside down V like this. Now this does not have symmetry with respect to the origin, because again, if it had origin symmetry, this arrow would have reflected over here. So I don't have that. So if I look, I think that if I called this my mirror and reflected, it goes left to right. So that would mean that this function is called blank because it has symmetry with respect to the y-axis. The y-axis was my mirror, and that's called even. So on to number 3. So we're going to do increasing first. Increasing means that if I were to draw little lines, they would be positive. Like this piece is, all of these pieces are growing. So this piece is my increasing, and decreasing. Increasing also you can think about like on increasing, you have to climb up, but decreasing you would slide down. So if I were decreasing, this side would be where I decreased. At the very top of the hill, this maxima right here is at -4. Remember, for increasing and decreasing, we're always going to use the x values, and we're always going to use parentheses. So for increasing, we're using x values, so I'm going towards negative infinity until I get to my -4. So negative infinity to -4. But for decreasing, I don't start until -4, and I go towards this way, infinity. So -4 to infinity. And just for a quick little review, this dot right here, it's a max, and we would call it an absolute max because it is the highest point. Both ends or both arrows of the graph are going down, so that blue dot is the highest point on the entire graph. Which leads us into number 4. Identify the following key features of the graph of the function that is graphed. So I have this dot right here and this dot right here. So this first dot that I made, it's a max and it's called a relative. Because this end of the graph over here is going up forever. So it is not the highest point, it is just the highest point compared to the things around it. The second dot I drew is a minimum, and it also is a relative. Because this end over here is going down forever. So this is not the lowest point, it is just the lowest point compared to the stuff around it. The y-intercept is right here. And that dot is 0, 2. Zeros are x-intercepts. And I have a 0 right here. I have another 0 and another 0. So my zeros are x equals -3, 2, and 5. If they were to ask you what the x-intercepts were, we would write them as points. We would write -3, 0, 2, 0, and 5, 0. These are the x-intercepts. But when they ask you what the zeros are, it's just x equals. The domain. Domain is left to right. So to the left, this graph is going towards negative infinity. It's not stopping. And to the right, it's also going towards infinity, never stopping. So negative infinity to positive infinity. Range is the down to up, the bottom to the top. So the bottom down here is going towards negative infinity, and then I move along my graph, and I go up towards infinity. So negative infinity to infinity. Number 5 says the graph shows the height, h, in feet of a roller coaster t seconds after the ride starts. What is the domain? Make sure you read domain. Domain is my x values. Left to right. So on the furthest tip left over here is 0, and I move along my graph up and down, but I really care about how far left and right I went, all the way to 70. This is a real-world problem. So when time starts, I'm physically touching the time of 0, and then as time happens, until 70 seconds later when the time stops or the ride stops, which actually happened, I touched 70. So my domain is 0 to 70 with brackets on it because I actually touched the endpoints. Number 6, identify all the zeros. You absolutely should be able to pause the video at this moment and answer this question because in number 4 right above it, we found zeros. We talked about zeros. They are x-intercepts. They are also called roots. So I have one right here, and right here, and right there. So x equals -2. Try that again. X equals -2, x equals 1, and x equals 4. Oopsie, sorry. On the next page, we have some more problems to do. So number 7 says, describe the discontinuity occurring at x equals 3. So look at the first graph. I literally have to jump. So this is called a jump. On the next one, if I look at 3, this red dotted line is called an asymptote. And here at 3, that open circle is called a hole. It's a point I don't touch. Number 8, we should definitely be able to do. You could even pause the video and try by yourself, but it says what type of extrema? Extrema means max or min, and then you have to include relative or absolute. So I'm going to go to x equals 1, which is right here, and find that dot. And that dot, that top of the hill, is a max. But since both ends of the graph are still going up, it's just a relative max. Number 9, it says find the domain. Remember, we had some rules. No dividing by 0, but we don't have a fraction, so we don't have to worry about this one. And then the second rule was the square root has to be greater than or equal to 0. I can't square root anything that's negative. No square rooting negative numbers. So the thing under my root, my 3x minus 90, has to be greater than or equal to 0. I can square root 0, but I can't square root anything smaller than 0. So I'm going to add my 90 over to the other side. Treat this like an equal sign. If I add it to one side, I have to add it to the other. 3x is greater than or equal to 90. And then I'm going to divide both sides by 3 and get x is greater than or equal to 30, which we can write as, I'm going to start at 30 and get bigger. You also could graph it. So let me show you in Desmos. So you could type y equals square root of 3x minus 90. And I'm going to have to pinch and zoom out because you can see my graph starts here, right there at 30, and goes to the right, which is bigger. Whoopsies, did not mean to turn that, sorry. Okay, and then we're going to do number 10. It says label each as odd, even, or neither. So let's start with even. Even means I'm symmetrical to the y-axis. So if I draw this line, that's not the line that cuts me in half, so that's not even. This line does cut me in half, so this one's definitely even. On letter C, it cuts me in half, but I don't mirror image the dot over here, so that's not even. And the last one, I draw my y-axis, this dot should be reflected over here, so it's not even for that graph either. So we've labeled the one even. Okay, so let's try odd. Odd means it's origin symmetry. So if I go to the first one, origin symmetry means this dot over here would have reflected over there. Well, that didn't happen. So since this first one's not odd, and we know it's not even, then we call this neither. Letter B we already knew was even. Letter C, origin symmetry. This dot reflected across the origin that way. That's definitely origin symmetry. So this one's called odd. Remember, odd origin, odd origin. This one, if I put a dot here, this dot did not reflect to the origin that way, so this is not odd nor even, so we call it neither. On to the next page. Oopsies, okay. As x approaches negative infinity, what is f of x approaching? So we're going to look right here. We're going to go to the left. As my graph goes to the left, the graph is approaching this asymptote, which happens to be at -4. So f of x is approaching -4. The height of the graph is going to -4. Number 12 says evaluate the step function, so we're going to go find f of 2.6. So 2.6 is my x. So I'm going to go to my x-axis and find 2 and a little bit. Oh, hang on. I think it should be closer to here. 2.6. And that's the line I touch, so I go over here, and I'm touching the height of 4. So f of 2.6 equals 4. (13) says f of x is represented by the graph below. For what intervals is it decreasing? That means the graph's going down. So this side is definitely going down. It's getting lower and lower. And this piece right here is going lower and lower. So this goes from negative infinity, The x's are going this way until I get to this x dot right here. So my answer has to have negative infinity to negative 0.92. Well, letter A is not right. Letter C doesn't have it. Letter D doesn't have it. And just to check B, this dot starts at 2.7 and goes until 4, which is what that one says. Right there. So my answer is B. Number 14 says, what is the domain? So we can look at the picture, you can do all the things I've taught you, but if you look at the graph and just trying to put words to it, I go to the right to the infinity forever, and I go to the left to the negative infinity forever. But the one thing I don't touch is negative 4. So x cannot be negative 4. So if I look, it's not A. I can't be everything. It's not C. B is a little bit tricky, but B is not right because this negative 2 is the y, is not negative 2, sorry, positive 2 is the y value. I don't care about the y value when I'm talking about domain things. I care about x things, which is only I can't be 4. So or negative 4. So my answer is D. Go on to your next page. Okay, on this next page, it says, first problem, that I need to compute g of f of negative 2. So I'm going to start here with the inside. I need to do this piece first, f of negative 2. So f of something equals, when I look at f, it's 3 times negative 2 squared minus 6 times, actually, hang on, let me repeat that. F says 3 times something squared minus 6 times something plus 8. And the thing we're plugging in right here is a negative 2. So all the parentheses get a negative 2. Now make sure when you put this in the calculator that you use the negative sign. And this one's a negative. But if you look at this one right here, the 6, this is a minus sign. So on your calculator, you make sure you use the negative sign versus the minus sign. You can take this whole thing and put it in your calculator. I don't have a calculator in front of me, so I'm going to math it out loud. A negative 2 squared. A negative times a negative is a positive. 2 times 2 is 4. 4 times 3 is 12. A negative times a negative is a positive. This is going to be another 12. 6 times 2 is 12 plus 8. And then we can regroup and say that this is really a 20. So 12 plus 20 is 32. So this inside piece alone is a 32. So now I have to find g of 32. Well, g says 2 times something plus 10. And the something that we're going to plug in is this 32. So 32 goes in those parentheses. And again, you can type it in your calculator. I'm going to do it out loud. 2 times 32 is 64 plus 10 more, which makes an answer of 74. We'll go to number 16. It wants us to compare the two and describe how they're different. So we have to tell what this 3 did, what this minus 8 did, and what this minus 2 did. So the 3 is out front. It's a boy thing, so it's vertical. It's making the y's bigger, multiplying by 3, so it's a vertical stretch by 3, or vertical dilation stretch by 3. And the inside of the parentheses, this minus 8 is with the x, so it's going to be the backwards. It's the girl thing, it's backwards. So instead of minusing, we're going to move to the right, move to the positive, 8. And then at the end, the minus 2, again, this is a boy thing, it's an up and down, so this is going to make the graph go down 2. Okay, let's do 17. 17 says it wants g of f of 0. I'm going to start on the inside with f. So I need to go to the f graph and find 0. And then I go down to the graph and find the y value. So f of 0 equals negative 2. I need to take this negative 2 and then plug it into g. So I'm looking for g of negative 2. That negative 2 is an x, but I have to be in the g graph. So I go to the g graph and find my negative 2. And I go down to the graph and find my y value, which is right here, which is negative 3. So this answer here is negative 3. Go over to number 18. Given the two functions, determine f of g of x. So this is f of g of x. So I'm going to take my f. It says f of something. So let's go to f. F says 4 minus 5 times something. And the something we're going to plug in is g. G says x squared minus 3x plus 8. So if those parentheses get that, so do the other ones. X squared minus 3x plus 8. And now I just need to do a little bit of algebra. I need to distribute the negative 5 into everything in my parentheses. So I'm going to have 4, negative 5 times 5x squared, negative 5x squared. Negative 5 times negative 3 is a plus 15x. Negative 5 times a positive 8 is a negative 40. And then I can combine my 4 and my negative 40 as like terms. So I have negative 5x squared plus 15x. Negative 40 plus 4 should get me a negative 36. There is my answer. Number 19. I'm going to color code really quick. I'm going to call the top piece the red piece. I'm going to call the middle piece the blue piece. And I'm going to call the bottom piece the green piece. So when you're doing this, you need to make sure you look at the restrictions over here on the end. Look at the restrictions. The first one says 8. So if I look at the red one, 8 is not less than negative 1, so it doesn't go on the red piece. If I go to the blue piece, 8 does not live between negative 1 and 4, so it's not the blue piece. But if I go to the green piece, 8 is bigger than 4. Now this green piece is a little tricky, because it says if x is bigger than 4, well, this is my x, that's that piece, 8 is bigger than 4, then my answer is just 5. So this one just equals 5. Done. The next one says negative 1. So take a second, and what color does this go to? Red, blue, or green? If you've said blue, you're right, because right here it says that it equals negative 1. Negative 1 is equal to negative 1. So I'm going to plug that in to the blue piece. So the blue piece says something minus 2 squared minus 4. And the something I'm plugging in is negative 1. Now just be careful. This is a negative sign. This is a minus sign. And this is a minus when you type in your calculator. So negative 1 minus 2 is a negative 3. I have to square that. A negative 3 squared is a 9. Minus 4. You should come up with an answer of 5. Let's try the next one, f of 4. What color does the 4 belong to? The 4 belongs to the middle piece. It equals 4 over here at the end. So same process as the previous problem. So I'm going to have something minus 2 squared minus 4. And the something I'm plugging in is 4. You can type in your calculator. I'm going to mental math it. 4 minus 2 is 2. Squared minus 4. 2 squared is 4 minus 4, which is going to get me 0. The last piece, negative 12 belongs to the top one right here. Negative 12 is less than negative 1. So this piece says negative 3 times something minus 12, and the something I'm plugging in is negative 12. Negative 3 times negative 12 is 36 minus 12. Which should get me a 24. Now we're going to go on to number 20. It says that it wants you to find g of negative 4. This is my x. I'm going to go to my x and find negative 4. This is my x-axis. This dot is an open circle. It doesn't count, so I have to keep going until I can touch it, and the y value there is 6. So my answer is 6. Okay. 21 says, which of the following represents the graph of the piecewise? Okay, so I'm going to start with the bottom piece right here. And on this bottom piece, it says my graph should be constant 6 if x is bigger than or equal to 3. So if I go to 3, I should be up at 6, not A. If I go to 3, I do go up at 6, but it's an open circle, and it says that I should be getting bigger than it. So it's not B. And now I'm down to C and D. So if I go to 3, and up here I'm at 6, but if you notice right here, it says greater than or equal to. So this dot right here should be closed in, not open. So it's not C, has to be D. And we're going to check it. I go up here, closed circle, getting bigger than. Good job. The top part is a line, like mx plus b line, with a y-intercept of -1, right there. And then I have to do my slope, up 1 over 1, up 1 over 1. That is the correct answer. Letter D is the correct answer. And then on to your last page. It says fill in the table for F inverse. Remember, if you're in inverse, your x's and y's switch. So all I'm going to do is copy down the y's into the x column and copy the x's into the y column. For 23, it says g of x is transformation of the parent function of f of x equals square root of x. Which of the following could be the equation of g of x if f of x is translated 7 units to the right? That means I should have an x minus 7 because it's a girl thing. So it's not A, it might be B, it's not C, might be D. Let's keep reading. A horizontal stretch. Horizontal stretches mean the number should be inside here with the x, not on the outside with the y. So let's check my two answer choices. They both have the number on the inside, but remember, it's a girly thing. It's backwards. So I don't want this, if it's a stretch, to be a whole number. I want it to be a fraction, the opposite. You think a fraction is going to shrink you, so it's actually going to stretch you. The answer has to be D. And they're both negative because the last piece says reflected over the y-axis. So that's why those were both negative. 24 says it wants me to find the inverse. So I'm going to go on my graph for a second. I'm going to write down these dots. This one's ordered pairs -3, -1. This one is -1, 1. And this one is 1, 7. So when I graph the inverse, these switch places. This first dot is going to become -1 and then -3. -1, -3. -1, 1 becomes 1, -1. 1, -1, the x and y switch. And this last one becomes 7, 1. And then you can see my picture. Also remember that to find an inverse, it's a reflection of the line y equals x. So this yellow line that I'm drawing in, it's not an asymptote, but it should be a reflection. Like my black should reflect to make my red over that yellow line. So we look at these two, and it says, are they inverses? So they have the same line in here that I drew. And just from the reflection alone, I would say yes. Like this little hump that way and that way, yes. And it says justify your answer. So one justification. They are reflections over y equals x. Another way is algebra. I mean, they gave you the two functions, so I can do f of g of x and g of f of x. And that would get me the cubed root of x cubed. And cubes and cubed roots undo each other to get me x. Same idea with g. It's the cubed root of something, which is x cubed. And the cube and cube root undo each other getting me x. Because these both equal x, they are functions. That's another justification. And it says for 26, determine if the given equations are inverses. So you will have a calculator and you'll have a Desmos. I'm going to add my Desmos. And we're going to graph the two of them. Y equals 8x plus 2. My other equation is going to be y equals dividing x minus 8 over 2. Now, just looking at these alone, they are definitely not reflections across the line y equals x. So I can say no. They are not inverses. Not reflections across y equals x. I could do the f of g of x just to start with. So that means f of something. F says 8 times something plus 2. Well, the something is g, and g says x minus 8 over 2, x minus 8 over 2. Multiply by 2 and divide by 2 is going to get me a 4 times my x minus 8 plus 2. Distribute the 4. 4x minus 32 plus 2. Combine like terms, 4x minus 30. Regardless of what the answer is, it has to equal x, not 4x minus 30. So they are not inverses. On number 27, before you do it, I need you to fix a typo for me. All of letter B's answers are missing a line. Can you draw the equal to line in? So typo, add in line in all choices for B. And I added in this line right here in all of them. So if I look at just the circles alone, just the circles, one side's open, one side's closed. So one side should be a less than, and the other side should be less than or equal to. Well, that gets rid of B and D. And I'm left with A and C. So if we look here, I just have a dot. Here, I'm at 4. Here, I'm at 8. Here, I'm at 12. So I am not 1, 2, 3, 4. I am 4, 8, 12, 16. So it's not C, it has to be A. And that is the last problem on your review. Hopefully this video was helpful for you. Good luck on your test.